Hello! Today we are going to learn about measuring force and frictional force. I have my friends Shaiful and Jasmine to assist me on these topics. Shaiful shall explain about measuring force and Jasmine on frictional force. Now, let's listen to Shaiful.
The SI unit for force is Newton. The symbol is N. 1 Newton equals 100 gram. 10 Newton equals 1000 gram or 1 kilogram. The unit Newton is named after a famous scientist and mathematician, Sir Isaac Newton. The instrument used to measure force is a spring balance. A spring balance has a spring with a pointer attached at one end. We use a spring balance to measure magnitude of force. When an object hangs on the spring balance, the weight of an object exerts a force on the spring. The reading on the spring balance is the magnitude of the force. Magnitude is used in stating the size or the extent of something. Let's measure the magnitude of force. Hang a book to a spring balance. Record the reading on the scale of the spring balance in the table. Repeat the activity using a pencil case and a wooden block. Let's look at the reading. The magnitude of force for book is 0.5 Newton. The magnitude of force for pencil case is 1.0 Newton. The magnitude of force for wooden block is 5.0 Newton. We observe that the weight of an object stretches the spring. The heavier the weight of the object, the greater is the force. Thus, the more the spring stretches. In conclusion, a force has magnitude. The magnitude of force can be measured using a spring balance. Let's study the principle of a spring and see the relationship between the force exerted and the extension of a spring. The initial reading of the pointer is set at 0 cm on the ruler. Place a 100 gram weight on the pen. Record the reading on the ruler in a table. Repeat the activity, adding the remaining weights one by one and record the readings. Let's look at the readings. Mass of 100 grams, the force is 1 Newton. Extension of spring is 2 centimeters. Mass of 200 grams, the force is 2 Newton. Extension of spring is 4 centimeters. Mass of 300 grams, the force is 3 Newton. Extension of spring is 6 centimeters. Mass of 400 grams, the force is 4 Newton. Extension of spring is 8 centimeters. Mass of 500 grams, the force is 5 Newton. Extension of spring is 10 centimeters. What is the extension of the spring when the mass is 600 grams? Based on the readings of the table, we can guess that the extension of the spring is 12 centimeters when a force of 6 newtons acts on it. From the readings, plot a graph showing the extension of a spring versus the force that is applied. The conclusion based on the graph is a straight graph is obtained. The greater the force, the more the spring extends. The extension of the spring is proportional to the force exerted on the spring.
Alright, we now know that the SI unit of force is Newton. The spring balance is used to measure the magnitude of force, and the extension of a spring is proportional to the magnitude of force extended to it. Now, let's listen to Jasmine. Jasmine shall talk on frictional force, direction and magnitude of frictional force, and also the effects of different surfaces on friction. So, listen to Jasmine.
What actually is frictional force? Well, frictional force or friction is the force that exists between two objects in contact. The existence of friction can be observed through the following examples. This is a block of wood. Let's push this block of wood along this plank. Ready? The block of wood moves and eventually comes to rest. Why do you think this happens? This is because there is an opposing force produced by the plank on the block. That opposing force is friction. Friction slows down or stops moving objects. Frictional force or friction can also exist between stationary objects. What do you think will happen to this block of wood when I lift the plank like this? The block of wood does not move. You see, friction prevents stationary objects from moving. So, we can say that friction slows down or stops moving objects and prevents stationary objects from moving. Friction has direction and magnitude. Let's identify the direction of frictional force and measure the magnitude of the frictional force. For this experiment, we will use a wooden block and a spring balance. First, hook the spring balance onto the wooden block. Now, pull the wooden block until it moves. 1 Newton, 2 Newton, 3 Newton, 4 Newton. It moves. The wooden block moves when the reading on the spring balance is 4 Newton. At first, the wooden block does not move because friction resists motion. When a stronger pull is applied, the magnitude of the friction also increases and the wooden block moves. The wooden block finally moves when the magnitude of pull is larger than the magnitude of friction. The magnitude of friction is at the maximum just before the wooden block moves. From the activity, we can conclude that frictional force or friction acts in a direction opposite that of motion, and the maximum magnitude of friction is 4 Newton. Let's move on to the effects of different surfaces on friction. You see, the magnitude of friction varies with different types of surfaces. How does the roughness of a surface influence the magnitude of friction? Let's find out. Here, we have a wooden surface, a glass sheet, and sandpaper. First, place a wooden block on the wooden surface. Then, hook a spring balance onto the wooden block. Now, pull the wooden block until it moves. 1 Newton, 2 Newton, 3 Newton, 4 Newton. 1 Newton, 2 Newton, 3 Newton, 4 Newton. The wooden block moves when the reading on the spring balance is 4 Newton. Let's repeat the activity. This time, we'll use a glass sheet. Place the wooden block on the glass sheet and hook the spring balance onto the wooden block. Now, pull the wooden block until it moves. 1 Newton, 1.5 Newton. 1 Newton, 1.5 Newton. The wooden block moves when the reading on the spring balance is 1.5 Newton. Now, we'll use sandpaper. Place the wooden block on the sandpaper and hook the spring balance onto the wooden block. Now, pull the wooden block until it moves. 1 Newton, 2 Newton, 3 Newton, 4 Newton, 5 Newton. 1 Newton, 2 Newton, 3 Newton, 4 Newton, 5 Newton. The wooden block moves when the reading on the spring balance is 5 Newton. Let's look at the results. Types of surface. Wooden surface. Magnitude of friction, 4 Newton. Glass sheet, 1.5 Newton. Sandpaper, 5 Newton. The small reading balance recorded for the smooth glass sheet shows that the glass surface is the smoothest. Friction acting on the wooden block is the least. The big balance reading recorded for the sandpaper shows that the surface of the sandpaper is the roughest. Friction acting on the wooden block is the largest. So, we can conclude that the rougher the surface in contact, the greater is the frictional force acting on the object.
So, from Jasmine's explanation, we know that friction slows down or stops moving objects. Friction also prevents stationary objects from moving. We also know that friction acts in the direction opposite to that of motion, and the magnitude of friction is at the maximum just before an object starts to move. Jasmine also did some activities using different surfaces on friction. From the activities, we know that the rougher the surface in contact, the greater the frictional force acting on the object. That's today's lesson. Goodbye.